That's you. Okay, let's see if everybody can connect to the Zoom session, or at least the people that want to.
I think you may have had the signature wrong.
Do I?
Chase on James.
Well, I better fix it. Thank you. That's what I need to know. I'm like, I'm sure. No, I'm not.
Basic first chapters. Yeah, I think that. There you go.
Is that better? Okay. How can you two look that much alike in this crazy picture? Not that much, but just enough to confuse me. You guys are so far away. We have to get things to throw at you. Let's see. Okay, I think I'm getting it here. All right, if you can connect. Let's try this. I'm going to see what I can see, because it's a little different for me up here than what I'm used to too. So if we have a group that would take over, let's see what it's like. Figure everything out around here.
Yeah, go. And what if there, and then you can just oh, you need to change. Maybe that. Yeah. Save it.
Martin, you have Greg here. Is anybody else in your group here? Just you and Greg. So we'll kind of wait on you guys and see. So they slow pokes in the snow or something.
Maybe they don't know space.
I'm looking for the thing yeah, that's why.
Oh, here. I think it's thinking there's two projects. You know, C# core, C# design. I have my work program for that. So like if you grab this and put that there. So I grab this trigger, maybe I just pull it out,
That's gonna
drop it.
see the
And delete that. Make sure that you have that. Yeah, they need nice steps. It jumps back. Smart, at least smart enough to save them space.
make sure to save it into my work. CIS. Down in there.
What's this choice?
Yeah, post
Did
process.
Process.
you guys send it out to each other maybe?
I don't think so. I think we got similar.
That was like something they need to add to this.
Yeah, you can add to that.
I think I did.
Oh. I hate it.
What was the problem?
He actually then created like another
Oh,
like.
I'm glad we're resolving all these problems with this little program.
Project. So we had pretty much two separate programs. And so you can move that file. So that way you find it.
It was kind of a rough day.
To stay fast.
Section. Get to the something else. We have. Our back row guys are gonna take over the Zoom session for us first and show us what they've got. Some of you have some issues, and I think that's good. I would rather have issues with a small project like this that isn't really worth a lot of points. We just wanted to kind of do some work and try some if statements. So let's use that like we should always use that as a learning experience. Make sure you know where Visual Studio is saving your project. Make sure you know where it is, because these brand new computers didn't care about where you were saving them before, which always gets us. So if you guys will show us what you did. Now we have back here Sebastian. Is that Matt beside you?
No, it's Chase.
Chase. Okay, good, because that's what I put on the seating chart, but I was starting to question myself. So you guys aren't actually in the same group?
No.
All right, we'll take it. Okay, you guys take it too. Okay, tell us what you got here.
It's like really similar to like the last thing on the Red Bull assignment. I just kind of switched like the output of like the choices, or like the user input choices. It's kind of like made up on the boards and what number you pick.
Well, so this is a nice class, and then is your program.cs file? Run it. Awesome. Can you run it for us? That's great. They implemented a class for that.
That's like this, and you hit it for or you hit a number and insert. It's turned off.
Not that number.
Oh no, it's just closing.
Do control F5.
Yeah.
Insert the console of quick key or quick line and now stop there.
Yeah,
Insert
no.
the end of the menu. Insert the console now quick key or line. So in the main program.
You show us. He wants to keep that console open to see if we can see a message.
When it's not here, you wait for it.
On my computer, here, I wouldn't do that. I got it.
Then it's on the next set.
Okay. No, it just doesn't open.
It says it failed. Do you see the error screen? So we can see what the error was. Zero errors. That's nice. Do you guys see those messages down there? Take a really close look at them. Do you see what else coming up down here? Is that anything that they did in the program? Can you see all of those error messages? What's it say? Could not copy something from this folder to this folder, beginning retry. So to me, it looks like a security issue, like it's not letting him create those files on the C drive to build.
Folder instead of the solution project. 'Cause when I did, I was
We
looking
could
at
do that. Let's check it. This drop down right up here, because that could be causing that trouble too. If we're looking at that folder, we might not be able to update it. Do that drop down and choose the solution option. Yeah, right there where you are, up there on that icon. And now try to build it. It's downloading something for you. Are we getting more? Unable to copy. So
Might be
on the solution, if you would right click on your solution and choose Open Folder and File Explorer. Let's close Visual Studio now.
Completely.
And let's copy your whole project. So we really want to go up one and we want to copy your award system folder. So go to your C# projects.
C# projects, and then just copy that folder. And then we might have to do, see, that looks like it's all,
With the.
it's all on your OneDrive. It's not on the C drive. Does anybody else have any trouble if you try to rebuild things?
I
mine
use
works
them
fine.
for because the OneDrive when it try to update file and if that project is stopped right there, it misses some files. So it will wait until the OneDrive update finish and then
And then it was okay after that.
you can check that one.
So you said it didn't sync properly?
Or it just takes taking so long to sync that you might have to wait
Yeah.
to be able to build.
We're going to show the error, but now it didn't show it. You can check your OneDrive, where you have drive, on drive, how it works. You can try one more time. I think it might work now. That's it on file.
Okay, let's try it. Here in just a few weeks, we'll be looking at a cloud-based facility, kind of like GitHub, for you guys to store your software. So we just need to make it a few weeks. If we start having too much trouble, we can start.
Couldn't copy it, so sorry. Not by match.
And let's change this view up here again, back to the solution view. And we probably are getting the same thing, but let's make sure. Yes. What we're going to do is have him close that. And I was like, yay, it's working. He's going to close that and he's going to restart his computer to see if some Windows updates or something have been installed. It's keeping it from working properly, and then we'll come back. So does anybody else have a beautiful if statement application to show
I have a switch.
Let's see it. A switch would be great. Let's see if it'll work. If we can cause some trouble.
Okie dokie. So, like everyone else, I noticed that it was very similar to the REPL. So I have two files. So here's my main. And then this right here, so let me zoom out a little bit. Maybe not that much. Is my separate class of word menu. I have my menu right there. And then this right here is the outputs. This right here is a small function that gets the input. So if we were to run it and do your race rank. So if we got first, oh, not 14th. If we got first, yay, gold. And if we got fifth, oh, not that. If we got fifth, you ran.
Or walked or something. Let's see that awesome switch statement. Tell us about that thing of beauty.
Well, there are 5 cases, 1, 2, 3, 4, and 5, and then I have a default. Each case is similar to an if or an else if statement, and the default is similar to an else statement. Right, so if I enter anything that matches the case, it'll print whatever is in that case, or execute whatever's in the case, not necessarily print. And then if it doesn't match any of them, then it'll execute whatever's underneath the default.
Awesome. Any questions? Looks great. Thank you. Anybody else? Go for it. Let's see. Someone's got their hand raised. Do you want something? How do I work it?
Need to get better at that.
So, right here, I just try to try pass to check the input from the user, return my number here, and then some result checking over here, and then statement change the condition of the user input. So that right. I mean, when it converts from the user input into the number, correct? Something so that the number in the range from 1 to 5, that's minus 5. And then now that the input from a number, you switch. Okay, my number from 1 to 5, 1 to 4, and then the last one 5, and we record. And then it's bring out the word. And that's it.
Really good. Any questions? Excellent. Does it run? Yeah, we should check that on all of them, huh?
Like you while look or things like more for
I don't think we saw the console screen there. That's all right, though. I think it's beautiful. Anybody else? What I'll do is I'll create an assignment on Canvas later for you guys to submit those, and so it'll kind of be more extra credit than actual points, because I know it was, you guys had to wait around for that sub. I don't even know what time yeah, because I mean, I didn't get the email that she accepted the sub request until like 10 till 8, so I kind of figured she might be late. I didn't know where she was coming from, but I was just like, go woman, go, you know, so I didn't know how many people would be left. So we'll get you guys some bonus points for that, because I know it's rough. We hate it. Try to make it worthwhile, and I think that you guys did great. I really like seeing the class implementations and using the switch statement and such advanced stuff. I'm going to share my screen here. See if I can figure out how this computer is working yet. So I've got most of my stuff up here hooked up, but not everything. I'm going to look at Canvas and go to our repeating instructions presentation, but I want to make sure that I'm looking at the right thing as we get started. Now, whenever we get into repetition, the feeling that you guys are just going to breeze right through it without any sort of problem, it can be kind of an area of confusion for some people. When you're looking at the REPL, there should be videos for a lot of them. These videos, like the other REPL videos, I think might have technical difficulties. My webcam hates me. Audio on computers hates me. The sampling rate just doesn't sample my voice right. So sometimes I get no audio on videos, and it's just really annoying. So they're there. They might just make you mad, but hopefully not. So if there's one that's really, really messed up, let me know and I'll see what I can do. Another thing that is on this lesson is the programmer website. Have you looked at that yet? I'm going to click on this programmer challenges and then next. And I want to go to their actual website, see if it will load up. Maybe. kind of a connection to Canvas, so sometimes I get some sort of mad. I'm going to search for it. Program R, your online code lab, and that's what we're really looking for. So I apologize if Canvas and Program R get confused with each other. I say they actually have a link in Canvas, which sometimes makes it worse. Whenever you use this site, it's really awesome because sometimes the hardest thing to get yourself going in a new language is to think of projects to do. You know, what should I do? What can I try? And this site just offers a whole bunch of different challenges of projects that are out there for you to try. I do think you have to sign up, though, to be able to use any of them. So I'm going to log in and then go back and see if I can use that link in Canvas to get to the right place. See if I can remember how I logged in. I could sign up. That's not going to be very good. Let's see if I used my OTC email. So if you already got an account created and you're working with it, that's great. The links that are out there on Canvas are just to specific project assignments in Program R thing, so that it can ask you to do projects that are applicable to where we are. So they're projects that have to do with basic review and if statements. And you see there's lots and lots of different languages that you can use. So you can try practice projects and things in different programming languages. See if it sent me anything. It'll send me an email and say, oh, did not find that email address.
Seems to like freezing up for at least
It's right.
me and Jake.
Is it freezing?
James. It's freezing up when we try and sign up.
Let's see if we can.
Takes quite a few seconds.
Let's see. Okay, let me get on. Is it just hanging on you?
Yeah, we can't sign up right now.
Because they go to let him, but wait, that's me. Just hanging.
Clicked it a lot.
And it just won't do a thing.
This might ask questions wrong. Wow.
Yeah. Yeah. It's not letting him get past the math question. He seems to have it right since it's 15 plus 1, but it keeps saying it's wrong.
Maybe you have to type out the whole thing.
The whole word, maybe?
Like the whole, it's like 15 plus
Will it
1
let you
equals.
put letters? No. Oh, you could do that 15 plus 1 equals 16.
I tried.
Retyping the formula. It's just broke.
Okay.
These silly programmers. Who do you think wrote this thing? There, you got it messed up.
Like 56. Because it's not just one level, it's, you know, 100. sometimes shakes up.
Let's see, I'll go to C# so we can see it. And I think it's letting me log on since I already had an account. When I look at all these projects, there's just tons. So I'm looking at the challenges. Those look a little bit more interesting. Lots and lots and lots of ideas. I won't let you guys click on anything without being logged in. I'm going to try to use our Canvas link. I'm going back to the rectangle. Oh, and it actually let me go to it. So if you are able to ever get an account created, I will email them if you can't, and they'll figure it out. And when you click on that link in Canvas, it should take you in to do this. So maybe we should do this one together because it's kind of neat. Let's take a look at our repetition statement, and then we'll try it because we just want to make a triangle here out of stars. So before we do that, let's talk about how we format our repetition statements. The video that's out there is just a lecture video, but I'm going to save that PowerPoint. So I want to make sure I've got that one. I'll open it. Bright enough for you this morning. Okay, I think everything's working here right now at this moment. So yay, PowerPoint. Doesn't require a lot of resources. Whenever we are talking about repeating instructions, repeating code instructions, a lot of times we just refer to that as looping, right? Looping structures. The official term is repetition, that we're working with repetition statements. So whenever we're working with repetition statements, they're really just looping. We're controlling the flow of our code. Certain code can be repeated if a test condition is true. We can also set things up to where certain code can be executed until a condition is met. Or we could do like a predefined number of times, like if we want to try something 10 times. So any of those options are available to us. And we have different syntax that's available for those different types of options. So I want you to think about an assembly line here. We are working on painting cars. And we're going to just keep repeating these actions over and over and over until we're done for the day. We're going to check first, is there another car that we need to paint? If so, let's tape it off, move it to the paint area, paint it, and then move it out of the way to the drying area. And then we're going to check again, is there another car to paint? So this is a common assembly line type approach, right? This is an example of a top controlled loop, right? This condition here at the top of our loop is controlling what we do next. If there's another car to paint, we're going to execute our loop again. If there's not, we won't. So that's why it's top controlled. Whenever we're working with a loop with that kind of structure in C#, it goes really well with the while syntax. Now the while syntax, you might have already noticed because some of the rebels that you've done have had whiles stuck in there already. It is exactly the same as an if statement, except the keyword is while instead of if. Everything else is exactly the same. Our condition is enclosed within parentheses, and our
close within open and closing curly braces. Just like an if statement, if we only want to execute one line of code, if that while condition is true, we don't need our curly braces. And we can put it all on one line if we want to.
Okay, so that's our while statement syntax. Exactly the same as an if, except the keyword is while. So we just took our if statement and made it into a repetition statement with that while keyword. I think if we took these giant yellow things and spread them around over there, we could have like trampoline practice. Have you stepped on them? They're really bouncy. Those are the biggest cable conduit covers I think I've ever seen. In case we need massive quantities of fiber or something in here. Okay, so our while statement. Whenever we're working with it, our condition, like I said, is just the same as an if statement. So just like an if statement, we're going to have a decision diamond showing in a flow chart. If we were to flow chart it, we would have a true path and a false path and no others. So our while statement basically can only have the same number of actions as an if statement. Just like an if statement condition, these are the relational operators that we have available in C#. Less than or equal to, greater than or equal to, is equal to, and is not equal to. So just exactly the same. I have that stuff repeated just to kind of remind you. My test condition can be exactly the same. Now, the difference is that with a repetition statement, we're going to see some sort of probably backwards flow on our flow chart. We're going to see arrows pointing backwards instead of forwards. So in this example, we have a flow chart. We check the light. Is the stoplight red? We want to stop. I don't know what that is over here. I'm going to ignore it. Is the stoplight red? Yes. Stop. We're going to sit there and keep checking the light, you know, forever. When it's finally not red, we'll go. So our flow chart shows that looping structure by having those arrows and pointing usually back to the decision diamond where our looping condition is identified. So if we think about that, it can help us with our code. Just like when we're working with an if statement, we're going to have the order of operations that is applicable to our condition. One thing that we should notice when we're looking at something like this stoplight, it could be a Boolean, like a Boolean variable, and that might be a state variable that we could be looking at. So our stoplight, we're wanting to check, what is its state? Is it red? Everyone stop. Now, when we go into a while loop or any sort of repetition, we have three basic functions or things that have to be taken care of to make our loop execute properly. First of all, we have to do initialization. This might be setting some counter variable to 0 or checking our stoplight status. Whatever we have to do something to get set up, to set up our variables for our loop. Then in our while condition, the condition is actually going to be tested. In that testing phase, we're going to see, is the light red? And then there's going to be an update occur within our loop body. So in our loop body, we saw when we're checking the stoplight, we're always sitting there staring at it. Once we see it change, we're updating that light status to make it green. Now, if I didn't update within the loop body, my loop would never end, right? So I'd have to update somehow within my loop body. Let's find one here. Click, let it click. There it goes. Here's
an example. Sometimes when we're creating our condition, we want to do something while a condition is not equal. So these are some examples. While the size of the window is less than the size of the display, reduce the display size by 10 pixels. Or while the number of names input is less than 10, prompt for another name. Or while the number of tickets is greater than 5, can ride another ride. So in those kinds of situations, we might be decreasing some value within our loop body. Okay, so the first looping structure that we see with C# is the while condition. The while condition uses our conditional expression, has a loop statement body, and no semicolon on the while part. If you put a semicolon on your while condition, you just ended the while condition. So the loop body there will not be part of a loop body, it'll just be part of the program. Execute every single time. Okay, what about a top controlled loop? No, we just did top controlled loop. Here's another one. Here we have a test condition at the top again. Do I have chips? Pick one up, add some dip, eat that chip, check for another. We do this a lot. Look both ways before crossing. Don't count your chickens before they hatch. Those are all kinds of things we think of as checking the condition before we do something. But what if it doesn't work that way? What if we need to do a bottom controlled loop? In this case, we would have a test condition at the bottom of the loop. We could execute the while body, then check to see if the condition is true. Here's some syntax here. We'll look at it more in just a second. But in this case, we'd have the do keyword followed by our body, and then the while condition at the end. So while there are more chips. Now, some bottom controlled loops examples that you might think of. Don't judge a book by its cover, try before you buy, all of those kinds of things, control things at the bottom. So a do while statement. This is one that you don't have in Python, so it's a little bit different. And people find a lot of really good uses for it. So the syntax is, I start with the keyword do. Then I have open and closing curly braces. Inside my curly braces, I have my repetition statement body. But at the end, after that closing curly brace, I have the while information, followed by the conditional expression and a final closing semicolon, because this statement is a little bit differently formatted. So I have to indicate where the end of it is. So as you notice, there is no use of the do while with only one statement. We always have to have open and closing curly braces because it's a little awkward of syntax. And so we can't do the all in one line type thing either, unless we had opening and closing curly braces all in there. So the do while, whenever we have a do while, notice that loop body is always going to be executed at least one time. It's going to execute that loop body and then finally check the condition at the end. So we always get our loop executed once. Here's a while loop that's counter-controlled. Let's write this one. You want to? It's really short. Let's put it in Visual Studio so you don't have to just watch. Let's open that Visual Studio again. I've got to find it. There it is.
So I think I'm going to create a new project. And I want it to be a console app. It's amazing how much stuff your computer is keeping track of for you, isn't it, when you have to switch to a new one? Now I'm going to change my location again. Actually, if you remember, I was saving my stuff to the C drive in the other room because I'm just scary like that. Plus, I want it to run fast because if I put it on my OneDrive, then it's being super slow trying to copy it down all the time. Huh? Is yours never slow? Your OneDrive's probably happier. My OneDrive's really bad at least. Get all those links here. Mine might be extra slow. Actually, when we were doing Blender last semester, it got really slow. Trying to render things. Yes.
How do I get to downloading WordPress? But mine can't save as the. Did you open up? Try to open up the right type of file. File new. Project. Yeah, that's like something else. There you go.
Did you in it?
Yeah.
I think it's amazing how much switching computers messes with you. We should just do it every semester. People realize that. You guys did great at getting that all under control last time. Okay, so I'm going to leave mine on my C drive, bad girl, but I'm going to change the name of things, and I want to change the name of my solution first because I want to make it repetition practice. And this very first project, we'll just name it count controlled. Count controlled. That's right. Okay, so I've got this little program that I want to write. It's really, really short. I'm going to put everything in the main. I want an integer named count, and I'm going to set it to a value of 5. And I want an integer named iteration, and I'm going to set it equal to 0. And then let's create a while loop. Let's run our while loop while our iteration is less than our count. And then I can output. Now, whenever we're outputting here a parameter like this parameter 0, are you guys ready for a different way you can handle that parameter stuff in your right line? I think you are. So we're going to look at the interpolated options, which are so much better. Put a $sign before you begin your string. And now in our output, we're going to say this is iteration number. Actually, we can just put our variable name.
Yeah, like straight from
Mm-hmm. Yes. I don't know where they got it from. Maybe there.
that's what we learned in Python.
Mm. So the interpolated formatting statement starts with the $sign before the beginning of your string. And then when you use that, you can specify the name of your variables within the curly braces instead of using that parameter and replacement value. This is another one of those hard ones with C# because it's obviously so much better than the way we've been doing it.
but they've been doing it the way we've been doing it for a lot of years. So if we don't do it that way, you won't know what's going on. So we have to kind of look at that old way before we can appreciate the new way. I'm going to save all. And let's see, after my while statement, I think I'll go ahead and put a console.read or read key so that I don't have to worry about that console staying open. And I'm going to save again. Am I ready to run this? Let's try it. Am I broke?
Yeah, I'd like to add the implementation of the updating part of the iteration. You're using your process memory.
Do it.
So your process memory.
It's working. Oh yeah, I'm using some memory. Good. CPU, not so much. But I have created an infinite loop because I'm not updating our iteration variable within the loop. So I can add in a line to just add to our iteration variable. I'll put a comment there. Update for next iteration. And now if I run, I should just see iteration. This is iteration number 1, 2, 3, 4, or 0. 0 to 4. We should see all of that stuff. So let's label those important points in our implementation here. These two statements, creating our variables and setting them to initial values, these are getting our loop set up. And we said that that was going to be initialization. Where'd Visual Studio go? There it is. So initialization. And then in our while statement, we have our testing phase occurring. And then within our while loop body, we have our update for our next iteration so that our loop will end. So we have all three of those things we said we needed to create a valid loop: initialization, testing, and update. So that's a standard while loop. We have a couple of different things going on there. The count variable is really what is controlling our loop. We'll say that's our loop control variable. And then iteration, of course, is our iterator that's making our loop work. The next thing I want to look at is backspace. Let's add a second while loop. And we're just going to put it right after that first one. So I'm just going to copy my while loop. And then I think I'll change my output a little bit to say second loop iteration. How does that one work? What's the problem?
Because you need to either increase your count or reset the iteration.
For our second version, we didn't properly do our initialization step, did we? Because we have leftover values for our iteration variable from that previous loop. So we would need to initialize again, depending on how you wanted that to work. And then when you run, that second loop should execute. Good. So you just want some nice syntax for us. let's go ahead and create another project in our solution. So on your solution, right click and choose add new project. And let's name this one do while. So in our do while loop, we're going to use those same variables, an integer named count and an integer named iterate. But this time we want to use a do while. So I'm going to type that keyword do and then put in my open and close parentheses. I'm going to create a console.writeLine and I'll use the interpolated formatting. This is iteration number iterate. And just like a top controlled loop, I can still make it an infinite loop. I'm going to add my while condition. While iterate less than count. And then at the very end, close the entire while loop with the semicolon. Now I'm not adding to our iterate variable because I want to see that I can create that infinite loop with a do while. So I'm going to save this. And I keep saving because, bless you, there's been a lot of trouble in the past where Visual Studio would kind of lock up if you have an infinite loop. And so when you're doing loop, it's a little bit risky, but they save so much anymore for you, it's fine. So I'm ready to run this. I want to make sure this is the project that's actually going to run. So on my do while, I'll set it as the startup project. And press Control F5 since I didn't put a read key in there. And then of course you should be able to see it looping and looping forever. It's hard to tell because it doesn't really do much on the screen. I'll close it. Look how nicely it closed out of that. That's so nice. Now I'll go ahead and add the code to update my iterate variable. So again, just like before, we are initializing, updating, and then in our while statement, we're testing our condition. Good, good. So we have a couple here, practice ones. We need a few more though. Whenever we're working with these repetition structures, besides the count controlled type of loop that we've been working on, like I said, we could have state controlled loops where we're checking the condition of an object, or we could have a sentinel controlled loop. If you remember from your intro to programming day, a sentinel is like a key that indicates you should quit entering data, something like that. Like you might say, type the username or press 99 to exit. So we can do that too. Now, when we are getting to where we really want to pack everything into one statement, we can use our for loop. And so a for loop really has three parts. And the first part of the for loop, which is all contained within parentheses. So let's look at our syntax. We start out a for loop with the keyword for, and then open and close parentheses. Our for loop body is within open and close curly braces.
And within our for loop, the first phase is our variable that we want to iterate within the for loop. In this case, we called it iteration. And we include the if keyword saying we want to declare this variable. Now, if I do it this way, I can't get to this iteration variable after my for loop is over. I could declare iteration up here and make it a variable that is available throughout that method. But if I don't need it, use it anyplace else. I can say, oh, it's an integer, it's only in my for loop, and I want it to start with an initial value of 0, then a semicolon. That ends that first part of the for statement. The second part is our test condition. Our test condition could be whatever test condition we want. Top right equal red. In this case, it's while our iteration is less than our count. And again, a semicolon to say that's the end of the condition part. And then lastly, our update. So we want to update our iterator variable whenever we execute each section of our loop or each iteration of our loop. So let's put that one in our code. In Visual Studio, let's create a new project in our solution. And this one will be for loop. In our for loop, we're going to set up a count variable. Again, is our limit. And then our for statement. We want to create an integer variable called iteration with an initial value of 0. So that will be our initialization clause. Next, we want to execute this loop while our iteration variable is less than our count variable. That's our test clause. And lastly, I want to update the iteration variable with each execution of the loop statement body. Now my for loop needs open and close curly braces. And I'll put in console.writeLine. For loop iteration number iteration. And I left off my $sign. Now, if I tried to access our iteration variable after the close of our for loop, I won't be able to because it's only local to our for loop because it was declared as part of that for loop, local to the loop. So let's try it. I'm going to do Control F5, but first I'm going to make sure it's my startup project. And there it's going. So our for loop is just super handy. Now again, we would not be able to access that variable outside of our loop. But if we want to, we can declare it before the loop begins. And then we can just use that variable. We can still specify that we want it initialized to a value of 0 to start our loop. We just don't have to declare it within our for loop. Does that make sense? Just that little keyword int there is making that all that difference, is to that variable being local to our method versus that variable being local to our for loop. Let's speak. Now, just like any other type of statement, we can make things fun and exciting by nesting loops. So we can have
while loops within for loops and do whiles within whiles, and there is no limit. You can nest them as much as you want, make everything work however you want. Let's do this quick multi-level loop. So let's do one more project. And this one is going to be a nested for loop. I want to set it as my startup project. And this will be really, really short. We're going to have a for loop that is controlled by an integer named row. We want row to start at 0, and we want 5 rows. So we're going to set our test condition to be row less than 5. And we're going to add to row each iteration of our loop. Within our row, let's use console.write and output our row number. So I'm saying I want to go to a new line, and then I want to output the word row and whatever our row number is. We can control F5 and run that, and we should see our rows. Looks like that's working. So now I want an inner for loop. Now my inner for loop is going to go right after this console.write. So it's going to be within my curly braces for my outer for loop. And this inner for loop is going to be executed by or controlled by an integer named call for columns. And we want to run to print out 5 columns and add to our columns variable with each iteration. So I'll do a console.write, and I'm not going to specify a new line so that I can have it all print out on one line for each row. Get that fixed there. So now we should get, if you look at it and do some desk checking here, you should get output on a new line, the word row with a row number, then a couple of spaces, and the word call followed by a column number, and a couple of spaces and call followed by a column number, and a couple of spaces and call. So all of these should end up on the same row as our row output. Let's try it. Control F5. And there we go. So for row 0, we've got column 0, column 1, column 2, column 3, and column 4. So our nested loop is probably what we want to use to complete that programmer assignment. Compound expressions are the same as if statements. So you guys are ready to go because you already know how to use all your if statements. So let's look at that programmer thingy. Okay, write a program which takes input length and width of a rectangle as an integer and prints the rectangle. So first they say if length equals 10 and width equals 5, then the rectangle is like this. Well, let's just look at that program that we just wrote. Could we use this nested loop to accomplish that kind of thing? What if we created a couple of variables and said that we wanted to use variables to control these for loops instead of this number 5 here? So I could have like a height variable control how many rows I printed out, and a width variable that printed out or controlled how many columns. I'm going to copy or create a new project. And I'm going to name this one rectangle. And so I know, first of all, that I want an integer to hold the height. And I think they said for that first one, they want it to be 10. Length. I'm calling my length height. How's that? And width equals 5. So that's our limit. Now they wanted us to write a prompt method to input that information from the user, but we can just set it up to have some test data in there. So if I said for, I could do an integer named row, and while row is less than our width, I want to increase it. I guess if I'm talking about my rows, let me see then. I'm just going to do console.write. And I just want to output that star. I'm going to go ahead and label this. In my row 4. So should we get like 10 asterisks out from that? I'm not running it. Let me fix that. So I got some, but I only got 5. Am I using the wrong variable? Row should be my height, not my width, huh? And then I've got 10 stars. So that gave me a good row. So what do you think? What should we do there? I'm going to leave it with you to think about until next week, so we can look at it on Monday when we get started. Let's take a look at that REPL. We need some lab time for that. Take a look at this one. There's lots again, and they should all be small ones. So if one of them is getting to you and keeping you from moving on, skip it. Go to the next one and then come back to it later and see if it makes more sense now. It's like your ACT, skip it. Don't get stuck on it. So some of them might be super easy to you and really hard to someone else and vice versa. So that these are the kind of things that can really help each other with. So anyways, I hope the YouTube videos work or don't drive you crazy. All right, is it letting you get to it? Is the link working? Those ripple links I don't know. Okay, so things that I've left you with. You're going to try to create an account at Program R. Figure out why in the world it won't let you. You're going to figure out how to print out a rectangle. So much better, let me show you. And start on that rebel. And do let me know if you run into trouble. I haven't heard from anybody on the if statement one, so I'm sure you just all whizzed right through it. But remember, this one has a lot, so if you get stuck on one that you have to skip, just send me an email and we'll try to back up and figure out what's going on with it so you can get it all done. Any questions or anything then before you guys have lab time? Good. All right. Thank you.